All right, so this is our part 2 of graphing linears. In part 1, we looked at point form, which is that first form, and it's called point form because it tells us a point. Remember, it's opposite of the first number, so that's telling us that the point +3, 4 is on our graph. And then that number in front, that 2, is telling us to rise 2/1, 2/1, 2/1 through the point 3, 4. And then we talked about in the last video that the second one is called slope-intercept form, and a lot of people really like that one. However, I was trying to show you that in the last video. There's no real need for slope-intercept form. It's really point form in disguise. This is really the same as 5/2 with the x missing, and we would just, with the number inside the parentheses missing, and we would just throw in that +0, and it's still telling us a point, and it's still telling us how to move through that point. So there's really no need for slope-intercept form. It's really the same thing. Hopefully that doesn't blow your mind too much. I was thinking about mind blown, and then I was thinking about, do you remember this AT&T video about infinity times infinity? Mind blown. Anyway, so slope-intercept form, same really as point form, it's just disguised. You just have to fix it. But for this video, what I would like to talk about, is this third form, which again, I know feels frustrating, like how many forms of a linear can there be? It's really the same. We can make it look like the forms that we were just working with. We just have to fix it. So if you remember, our goal is to get y by itself, so it looks like one of those other forms from before where y was by itself in each of those. So we just need to fix it. So the first thing that needs to happen is the 3x needs to move to the other side of the equals. And if you remember, in order to do that, since it's positive, we will be subtracting it from both sides. When you come back to school tomorrow, if you don't want to show that -3x, you don't have to. You could just write the result if you would prefer. The result is that the only thing left on the left of the equals is 2y. And on the right, 12 is a constant, and -3x, is a linear piece, so those don't actually go together. We have to write them separately. And we always write the linear piece first, then the constant. Just some math etiquette. And then last, we need to get the 2 away from the y. Since it's being multiplied, we need to divide. Hopefully you haven't forgotten all of this. And again, you don't have to show me those steps in green. You could just show me the result, and I will be happy with that. All right, when we divide by 2 on the right, make sure you divide both the linear piece and the constant piece. So 3 divided by 2 is not super pretty, so we're going to leave that as a fraction. And then 12 divided by 2 is actually pretty. It's a +6. All right, and then, so keeping in mind, this is slope-intercept form, which you know that I would just rather us think of that as point form. And if I write it in point form, that means I need to think about the parentheses being there. And then the number that was inside that parentheses but not shown is a 0. So that's point form. And I'm not going to require you to think about it in point form. If you do really like slope-intercept form, you could just think of it that way. All right, either way, our start point that we're being told from our equations is 0,6. Plot that. And then our rate of change is telling us to fall. We will be falling through that point, and we're going to be falling 3 and going to the right 2. So let's do that really quickly. We will fall 3 to the right 2, fall 3 to the right 2, and you could also go backwards. And you know that I would prefer you to put as many points on the graph as possible so your line doesn't get wavy. But for a video, we'll go fast. All right, so that was standard form. And then, like I said, you can just take standard form and turn it back into slope-intercept form or point form, as I prefer. All right, so last thing that we're going to talk about with linears are these two kind of weird cases where there's just one variable and it doesn't really look like anything we've been doing. All of the ones we've been doing had an x and a y in it, no matter what we had done, it had an x and a y. And these just have a single x or a single y. And they're actually quite simple. That just means that it's either a horizontal line or a vertical line. Things you're going to learn about me this year is I hate memorizing. So I'm not going to ask you to memorize that x goes one way and y goes the other way. No, 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 no. Much simpler than that. This x equals 3 represents a line, and there are points on that line. And every point on that line has to have the x value as a 3. So I'm just going to make up some points. Oops. Let's get rid of that. Make up some points where all the x values are 3, and any point that has an x value of 3 will be on our line. So I can put whatever number I want in there. I can put any of these numbers in there and it will work. I'm going to plot those, see what it looks like. It should either be horizontal or vertical. So over, I can go 3, 7, 3, -4, and 3, 1. So if you had forgotten that just an x means a vertical line, now you can see from your points. And you didn't actually have to memorize anything. Yay. That was a horrible not straight line. Please don't do that. Okay. So again, when there's just one variable, it's going to be horizontal or vertical. I do not need you to memorize that. I just need you to know that when you see one of those, just make a few ordered pairs that satisfy that equation. So in this one, all the y values are 5. And I can pick whatever x value I want because all of those points will satisfy that equation since their y is 5. So let's just make up some numbers. And we'll plot those and see, is it horizontal or is it vertical? So -8, 5, 3, 5, -2, 5. So if you had forgotten that just a y means horizontal, that's okay. There's no need to memorize. There you go. So for these cases like this, where it's just an x or just a y, just remember that it's going to be horizontal or vertical, not tilted at all. And then you can just make some points. There's no need to memorize. Okay, so just as with the absolute values, if I give you the equation, you should be able to give me the graph, but also we should be able to go backwards. If I give you the graph, you should be able to give me the equation. So with this first one, notice that first of all, it's a tilted line, so it will have an x and a y. We can kind of see, let's see what we can tell from the graph. I was nice and gave you points, so it's easy to count out that stair step. It is going down 2 to the right 3, down 2 to the right 3, so it's falling. So we know that our a value will be, whoops, backwards, down 2 to the right 3, down 2 to the right 3. Always rise over run, or technically in this case, falling over running. And then I would say just put it in point form, and you could pick any one of those point forms that you wanted. So let's say I just pick one of the points that's here. That point is -8, -2. So if I use those two to write an equation, in point form, I need my rate of change, and then my parentheses with my x, and I write in my point. Now, remember to change the sign on your x. So I need to make sure to put a +8 so that it means -8 on the graph, and then I can keep my -2. So that is point form, and I am totally okay with you leaving it there unless I specifically ask you to do some more with it. So let's just practice that kind of quickly. Let's say I did ask you to write it in, whoops, too far down, in slope-intercept form. If you look back at the graph, the y-intercept is not perfect, and I do not want you to estimate. We will not estimate very much in this class. We will be as precise as possible. So if you had forgotten, a quick way to get to slope-intercept form is to just distribute out of point form. So if I do that really quickly, I'll just distribute that -2/3 through. So I would get y equals -2/3 x. I don't know how you feel about fractions, but you should at least have a calculator. That would be telling me, let's see, 2 times 8 is 16, so -16/3. And then I still have my -2 at the end. And then I can combine those like terms. Again, not sure how you feel about fractions, but you should have a calculator. So I'm going to think of 2 as the same as 6/3. So -16/3 minus 6/3. thirds would put me at negative 22 thirds. And in case you had forgotten, 22 thirds is 7 1/3, which if you look back up your graph, it does kind of look like we are crossing at negative 7 1/3. Okay, so that is slope-intercept form. And then moving actually to standard form is also not so bad. You can just, if you want to go to standard form, all you have to do is rearrange from slope-intercept form. Remember, standard form was the one where the x and the y were on the same side. It just looks all kinds of weird. So to do that, I would just move that 2/3 x over that negative 2/3 x. I would add it to both sides. And I would have 2/3 x over with that, it's a positive y, and I would have it equal to negative 22 thirds. And a lot of times in standard form you don't see fractions, so we might choose to multiply this whole equation by 3 on both sides equals. Remember, you can do whatever you want as long as you do it to both sides. So if I multiply by 3, it changes the whole thing, and that would give me 2/3 times 3 is just a 2. 1y times 3 is a 3. Negative 22 thirds times 3 is a negative 22. And that would be my standard form. I know that was kind of a lot for one problem. Let me just scroll back up. So really, if all I say is write an equation, you could stop right here if you wanted to. You have an equation. If I do ask you to move among forms, that's what this process would be. And we'll practice that a little bit tomorrow so you can kind of see how it goes. Okay? And then last graph, it is a horizontal or a vertical, so we know that it's going to be just a y equals or just an x equals. You know how I feel about memorizing. There is no reason to memorize on these. Just look for some points. Like this point is 2, negative 5. Grab a couple more. This point is 9, negative 5, maybe one back here. This point is negative 7, negative 5. What's common about all these points? They all have the same y value, so we know that this equation is a single y, no x at all, and it is always negative 5. So that is part 2 of our graphing linears and then also writing equations of linears.